Hey, welcome back. So in this lecture, we're going to go ahead and we're going to look at the solubility of a gas in a liquid. So here we have a liquid, whatever it may be. It doesn't really matter. It could be water. And above this liquid, we've got a gas. We've got a gas, we'll just call it X. And the question is, what is the concentration of X that dissolves in the solution? And presumably some of the gas will dissolve in there, right? So it can move down and get kind of absorbed by the solution. And of course, once it's in the solution, right, of course, it can come out and reform the gas. And the question is, how can we tell the solubility of the gas given the pressure of the gas? And it turns out that what you might expect is true. The pressure of the gas above the liquid is proportional to the concentration of the gas in the liquid. So the greater the pressure, right, the more the gas is pushed in and forced to dissolve in the solution. In fact, this is called Henry's law. So this whole idea is referred to as Henry's law. So Henry, and Henry was actually an English person, so it's Henry and not Henri. Sometimes people say Henry's law because a lot of these gas laws are named after French people, but it is in fact Henry's law. And Henry's law basically says the solubility of a gas, and I'll go ahead and write that as S, why not, is equal to the pressure of the gas above the liquid times by a constant. I'm going to write that in a different color, and that constant there we call K sub H, and the H stands for Henry. So this is referred to as the Henry's law constant, and it depends on the temperature, and it depends on the gas in terms of the identity, and it depends on the identity of the solvent, right, the thing that the gas is dissolving in. So it really depends upon a lot of stuff. So if we know the gas, if we know the temperature, and we know the solvent, then we can actually go ahead and look this constant up, and then we can relate one thing to the other. So let me go ahead and skip to a new slide and show you a table of these Henry law constants. All right, very good. So these are all Henry's law constants. Now, we are using water as our solvent for all of them, and we're using 25 degrees for all of them. And so 25 degrees is just kind of a conventional temperature we use in the lab. It's a little bit warmer than room temperature, but maybe a little slightly uncomfortably warm for me. And water, of course, well, we use water all the time. So here are a bunch of Henry law constants, and they're given in those weird units of molarity per atmosphere, and let me explain why. So the Henry's law equation says the solubility of the gas in the liquid, in this case in water at 25 degrees C, is equal to the Henry's law constant times by the pressure of the gas. And so we can get the Henry's law constant by just rearranging and saying it's the solubility of the gas in the liquid divided by the pressure of the gas above the liquid. And so you can see, solubility is going to have units of, well, whatever you like, but, moles per liter, molarity is very common. Pressure can have units of whatever you like, but atmospheres are very common. And so that means that K itself is going to have units of molarity per atmosphere. So it makes total sense. So in order to calculate a Henry's law constant, all you got to do is measure the solubility and compare it to the pressure of the gas, and that ratio gives it to you. So you can just look these up in tables. So let's go ahead and do a calculation. So let's go ahead and focus in on oxygen. And oxygen has got a Henry's law constant of 1.3 times 10 to the minus 3 molar per atmosphere. And we can use that to calculate the solubility of oxygen in water. So let's go ahead and write a question. So what's the solubility of oxygen in water at 25 degrees C at a pressure of 25 atmospheres. So let's say we are pushing on top of, say, a glass of water with 25 atmospheres of pressure. So let me go ahead and skip to a fresh new slide here. So let's kind of draw a picture of what we're talking about here. So here is our glass of water, or whatever it may be. It is at 25 degrees C, and we got a whole bunch of oxygen gas above, and the oxygen has got a pressure of 25 atmospheres. And the question is, what is the concentration of oxygen in that water now? So we can use Henry's law equation. We can say the solubility is equal to the Henry's law constant times the pressure. The Henry's law constant for oxygen was 1.3 times 10 to the minus 3 molarity per atmosphere, and the pressure of the oxygen was 25 atmospheres. So we can see the atmospheres will cancel out, and we're going to have units left behind of molarity, which is a pretty good unit for concentration. And I believe to two significant figures, it's something like 0.033 moles per liter. So, or if you like, 33 millimoles. So milli is 1,000th of a mole per liter. So not very large, I suppose. And we can increase the solubility by increasing the pressure. So if we want more oxygen to dissolve, then we can increase the pressure.